So, Assalamu alaikum everyone. Today we are going to study the basics of statistics. The idea behind today's session is that why we use stats and what are the basic tools that are available to us uh, that we will use later on in decision making. So this chapter is exploring the basic what we call basic tools that are useful. So we'll start with this chapter, and the topic of this chapter is that describing data using numerical measures. So the purpose of this chapter is if we have a big enough data, the data can be in an Excel sheet in terms of a column or a row or a column and a row. It can be a big data. Okay, especially in a banking sector, you can have long Excel sheets in terms of transaction data, or an auditor who is doing compliance can have to look at all the transactions. So, as a human, we do not have an ability to read all the data in an Excel file simultaneously. यानी अगर हमारा डेटा फाइल लॉन्ग है सो व्हाट विल हैपन इज दैट एज अ ह्यूमन हम सारा डेटा को एक साथ समराइज नहीं कर सकते कि व्हाट इज हैपनिंग अराउंड इट. सो अदर मेथड द पीपल यूज इज टू मेक अ ग्राफ. सो ग्राफ बनाने से भी पैटर्न्स निकल आते हैं, लेकिन द प्रॉब्लम विद ग्राफ इज that it is a visual way to describe something that is happening, but it will not tell you how high or high low. यानी अगर हम ग्राफ बना लेते हैं तो ग्राफ तो सिर्फ हमें बता देगा कि कुछ हुआ था, बट इट विल नॉट टेल कि वो कितना ज्यादा था या कितना कम. इट मीन्स टू से दैट इट विल नॉट टेल its severity until and unless we have some benchmark. So benchmark it itself is a number. So if we have a benchmark, we can then add that benchmark into the graph. सो ग्राफ में वो जो बेंचमार्क की लाइन आ जाएगी कि जी इस लिमिट से ऊपर चले गया तो बैंक के लिए अच्छा है या बुरा है, इससे नीचे आया तो अच्छा है या बुरा है. फॉर एग्जांपल अ ब्रांच मैनेजर कैन मेक अ चार्ट कि कितने सालों से उसका जो डिपॉजिट्स के टारगेट्स अचीव हो रहे हैं, वो टारगेट के लिए वो बेंचमार्क क्रिएट कर ले और एंड देन एक्चुअल डाटा को प्लॉट करके देखे. या हर ब्रांच लेवल पे रिस्क एनालिसिस हो रहा होता है तो ही कैन लुक एट कि कौन कौन सा रिस्क इंडिकेटर डिजायरेबल वैल्यू के करीब है, कौन सा दूर है. सो दिस इज वन वे बाय मेकिंग ग्राफ. बट द even if we have a graph, we need thresholds. When we need threshold, it means we are actually doing describing data using numerical measures. यानी हम numbers के through बड़े data को छोटे data में convert कर रहे हैं. So we are trying to summarize or describe what is happening into the data using fewer numbers, or what we call it जिस तरह हम what we call that we usually describe student using his CGPA value. Like if you complete your degree, when you go to some interview, you will say my GPA is 3.7. So this 3.7 is an average of all the assessments that you gave during the PhD course. It includes quizzes, assignments, class participation, midterms, final terms, all formal assessments. So rather than making a table of all the data by saying that in the first semester I got this much in the midterm, this much in the final term, so rather than giving that big data, the other side person might not have enough time to evaluate that long data. But if you say my GPA is 3.7, he will evaluate you very quickly. So that 3.7 GPA is one number that is describing your performances in all of your assessment. Those assessments were numerical. It means that जितने भी quizzes और assignments आपने दिए, उसके जितने भी answers आए वो mathematical answers थे. ठीक है? So this way you do it. The other example that you can use it, that whenever you apply for a visa or going abroad, they ask you for your bank statement, and bank statement itself is a very long sheet including how many expenditures were done and how many incomes were there, and at the end of the day, at the end of the below, the bank manager signs it that it is okay, or it is clear, or so that signature is a describing that his financial statement is fine. or the visa company has some threshold that he should have average this much of income in the bank at any point in time, so that we can consider his bank statement as a stable statement that his expenditures are lower than his income, rather than he has most of the time zero balance. बात समझ आई आप लोगों को that the financial statement maybe or bank statement maybe we use the numerical measures in our daily life. Now we will go towards our today's tools that we'll study. So this was the background about numerical measures. I tried to give you examples. We'll start with that. So we'll talk about that what are our goals for this chapter. We'll start with discussing mean, median, and mode. It is, and then other set of tools are range, variance, and standard deviation. Then the third set is box and whisker plot. Fourth set is coefficient of variance and z-scores. And at the end, we talk about how these data can be used in charts, graphs, or tables. How we can use them in our decision making. So this is our target for today's session. First, now we'll name these topics. First topic that we are going to study is the measure of center location. Center and location. So center itself is a location. So we need to, the first tool that we are going to study is, it will give you it will give you what we call it, uh, one number that describes what is the center of the data, or it will tell about that this number is at certain location in the data. So what is the advantages? Let's suppose this is our the lowest value in the data, and this is the highest value in the data. If we join it in terms of a number line, so this describes the data. So lowest value, maybe in a financial statement or a balance sheet, this is your zero income, because in your current account the balance cannot be negative. So it's a minimum deposit amount, and this is the highest possible balance that you had in your account. So this number line shows all possible values that data could had. So center can be a certain number that will tell about what is the uh, where is the most representative, most central, most repetitive, most ideal value of the data, or most habitual value that the depositor had. Yani we can say that if you ask on average how much deposit that he had every day. So what we do is we will divide the data into and create an average, and this will give us that on average his deposit account has this much amount. And location can be that we can ask him that, let's suppose, what is the 90th percentile value? What is the amount that he had about 90% of the time? That if that this is the amount that in 90% cases this amount is higher than that. कि अगर वो डेटा 100 दिनों का है, तो 100 में से 90 दिन ऐसे थे कि उसके बैंक के अकाउंट में इससे कम पैसे थे. 90 percentile means that if the data is for 100 days, he has the deposit amount. Let's say here we say that it is $500. So let's say that $500 is the 90th percentile value. The meaning is that during the last 100 days, uh, more than this amount, more than 90 days, he didn't have this much amount in his bank account. So this is one example. Similarly, other measures include percentile, quantiles. Then we will study about measure of variation. This talks about that how much individual values in the data are located away from the center, how much it is dispersed, how much it is scattered. So we can call it measure of dispersion or scatterness. So these are some tools. So let's move forward. Let me clear the screen. So in the next slide, we are making a table that how we describe the data numerically. We can describe in terms of center and location. We can describe in terms of other position in the data. We can talk about the shape of the distribution of the data. We'll talk about that when the slides comes. We can talk about the variation in the data, how it is varying. We can make some new indicator that can be used for comparison with some other data sets. So using these tools, we can make a new indicator that can be used as a comparative. For example, in our financial statements, what we do is rather than we use value of net profit, we use what we call it ROA. Since ROA is in terms of percentage and net profit is in terms of rupees, the net profit is not comparable across banks because that data depends upon how big the bank was. Maybe a smaller bank can have a big net profit because it might have lower risks, or a large bank can have a very big net profit because it has high assets. But ROA will compare that how much net profit was as a percentage of his assets. So that will be a comparative indicator across other banks. So this is one example that we'll study later on. I'll go to slide number 5. It gives us one example of measure of center. In this slide, we can see that there are three methods. We will see visual diagrams again and again. So I will try to talk about them accordingly. So first indicator is known as mean. The formula that is shown in mean is that we will add all the observations. So here the first sign is this is called summation. So summation means that everything that is written in front of it, we will add it for all cases. So if we have n observations, or total n, it can be 100, 500, 1000, we will add from 1 to n this x. So if we have the deposit data of a customer and he has 100 deposits, so total deposit size will be summation of all the deposits. So x can be deposit, so summation of x will be total deposits by that customer during that particular time period, and that can be n is equal to 100. So we are talking about 100 transactions that are deposited in the bank. So the numerator will become total, or in other words we call it sum total. Okay, so the numerator will be sum total and the denominator will be total observations, or we call it total cases, or total events, total number of events or scenarios, and this will become average, AVG, average. And the method that we use is called mean. So we can call it that this is mean, or in books the other word that is used is arithmetic mean. Arithmetic mean. So this is the method that is used to calculate sum total divided by observations, and we'll see that later on. There are two types of formulas that are shown here. First one is for sample, second one is for population. This difference we already studied in previous classes, that if we have a representative data from a bigger data set, then we call it as a sample data. Okay, So let's suppose we have this big data of all the transaction of the customer, but we are focusing on only the transaction happening in 2020 onwards. Then this region will be called sample, and if we take an average out of it, it will become sample. But if we pick all the transaction of the customer and evaluate its average, this region, this will become population, all the available data for that example. So this is the way we calculate differentiate between mean and sample and population. Similarly, let's conclude other two sets. Then the other method is called median. What we do in median is that we I will call first step is to arrange the data in increasing order, increasing. So we tell the Excel file or our statistician to arrange the data from the lowest to the largest, and then we count the observations. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we have 9 observation, it means the center value will be, which will be, it will be fifth one. So this is the central value because it has 4 values below it and 4 values above it. So this number, the fifth number, it has it's in the middle in terms of the order of the numbers. So this will become its median. It is and if the numbers are odd, even let's say the total numbers are 10. So what you will do is you will take fifth number and sixth number, add them and divide by 2. The value in the fifth position, value in the sixth position. So rather than I will write fifth and sixth. So this way it will become median. And then the next is mod. And in the mod, what we'll do is we look at the most repeated observation. So here the most repeated number is 3. Okay, so you will have to look at what is the position of this data. Suppose these numbers that are repeated are 3. So the mod will become 3. So 3 number is repeated 3 times. So this is most repeated number. So in the mod we'll say that 3 is most repeated number. It is not actually the number of repetitions. It is actually the position or the value of that observation. Let's suppose this is 10th observation and there are 4 circles here. So we'll say the mod is 10. So this way we decide what is the value of mod. Similarly, the third type, which is regularly used, is called weighted mean. It is mostly used in the data which is in table form, or what statisticians call it group form. So if the data is already compiled into a table form, then what we do is we use this method. For example, if I will create one example before moving to the next topic. Let me run a screen. So let's draw an example here. So let's suppose you have a table given to you by your supervisor, that let's say there are categories. Okay, so you have customers in terms of their risk, or what you call it, bad debt types. So this is, let's say, type A of bad debt, which is not that high, type B of bad debt, type C of bad debt, and you and say number of cases, you say that there are 50 customers in this bad debt type and there are 10 customers in this bad debt type, and this is severe case where there are only 5 customers whose bad debt is beyond 1 year. Let's say it is more than 1 year, this is more than 6 months, and this is more than 1 month. So bad debt type A, bad debt type B, bad debt type C. And these are number of customers or number of debt cases or number of profiles, you will say, that who are in the bad debt. And then he has written you the value of the average amount or debt amount. So he will say that the average loan, the loan that was given to them was for 1 million, and for them the loan was, let's say, make it bigger. This is 1 million, this is 0.5 million, and this is zero point 0.1 million. So there are three types of loans given, and this is the data that you already have. Now you want to calculate what is the average value of bad debt. यानी आपके पास तकरीबन 65 कस्टमर्स हैं, 65 customers, and first 50 were given 1 million loan, next 10 were given 0.5 million loan, and 5 were given 1 million loan, and or credit, and they are in the bad debt. Now you want to calculate what is the average amount. So in this case we will use the weighted mean method. So let's go to previous slide and see the formula and then solve it. So that is weight into the value divided by weights, sum of weights. So we'll come back to the formula again. So what I will do is now I will try to write the formula. Let's come back to diagram. So the formula is 50 into 1, weight into the value, plus 10 into 0.5 plus 5 into 0.1. I will add brackets so that they will be solved first. So this way and divided by total weights. So 50 plus 10 plus 5, that is 65. So I will calculate. So 50 into 1 is 50, 10 into 0.5 is 5, and 5 into 0.1 is 0.5, and then over 65. So answer will be 55.5 divided by 65. Okay, so this way then average will become is, let me calculate. So 55.5 divided by 65, that is 0.85 million. So average bad debt amount that the bank is facing is 0.85 million. So this is the way we calculated the average into the data, and you got the answer. So this was the topic about central tendency. Okay, so we have studied the types of central tendency or measure of center. So now he is giving the formulas that for the case of arithmetic mean or arithmetic average or arithmetic mean, the word is used. So it is the arithmetic average of the data. So what it does is it arithmetically creates average. So what it does is it adds the numbers that we saw earlier, that it calculates the sum total, and then divided with the sample size. So it gives you the arithmetic number. So it in other words, we call it net effect, that how many high numbers or how many negative numbers, it will calculate the net. So the sample mean formula is this, where n is small and the sample notation is x bar. For population, n is capital and this population notation is mu. So this is the arithmetic average that we discussed in the previous slide. Next we talk about arithmetic mean average in terms of number line. So let's suppose you have a number line from 0 to 10 and you have 5 observations. First is number 1, then 2, then 3, 4, 5, and then arithmetic mean will be sum total divided by total number of observations, that will become 3. Okay, so it is the most common measure of tendency. It is the sum of values divided by number of values, but one of the problem that it has is it is affected by extreme outliers. So let's suppose you have a data where the number 5 is moved to number 10. So this becomes an outlier. The definition of outlier is that a number which is away from the distance of that with the nearest is higher than the other distances. So this way you can compare that other distances are almost similar, very small, but this distance is very big. In this example, the distances are almost similar. So outlier is a number where the distance from its nearest is relatively very different from others. So this way you can say that it is an outlier. So but if you have an outlier and you calculate the arithmetic mean, the answer is different. So it means if you have a data and there is one outlier in it, outlier can be very big value or very small value in the data. So in both sides, it can be very small or very big. So it will change the data. So whenever we are calculating arithmetic mean, first of all, we need to make sure that does it have outliers or not. Because if there are outliers, we need to be careful in interpreting the meaning of the number. Otherwise, it will give us wrong answer. We will go through the examples in the next slides. So then there is a median. Median is not affected by the extreme values because it is only looking at the middle number. So if you have 5 numbers, the middle will be 3. If you have 7 numbers, middle will be 4. And if you have 9 numbers, middle will be 5. Fifth observation. So here are 5 numbers, so the middle one becomes this one. So this is the median in the middle. And for this case, the median is there. So the advantage of the median is that it is not affected by the presence of outlier and it gives the same answer that it should give. But the problem, one of the problem that median that books discuss is that median only use limited data. It only use the data of the middle observation. It ignores the data presence on the sides. But still, one of the advantages is that it will be in the middle. So this is the way we calculate median. And we go towards the next one, that is mod. So mod is also a type of central tendency. It focuses on the most oftenly occurring value. So what I call it, that mod usually uses most repeated case. Most repeated case. So this is the way. So this example is used mostly by one of the example that I gave is for the case of doctors, where they observe presence of any particular disease in terms of how many patients that they have. यानी वो क्या करते हैं, अगर कोई बच्चा बीमार आता है तो उनको पता होता है कि आजकल फ्लू की बीमारी चल रही है या आजकल मलेरिया ज्यादा है या आजकल डेंगू ज्यादा है या so how they guess which disease is predominant nowadays. They look at most often patients, how many of these patients are that he receives. So if majority are of flu, he will say to the next patient that you should be careful that the flu is very common nowadays. So this way the median is used in our decision making, and this is one example that I gave to you. So the median is not affected by extreme values because it looks at the most repeated case. Sometimes the data might not have any mod because in this example there is no repeated value. All of them are occurring once. But in this data there is 5 mod and there can be several mods. For example, this is also repeated twice, this is also repeated twice. So we picked up the most repeated value. So this becomes the mod. So mod, I have given you an example of where the mod is used in our decision making. Next is the weighted mean example, that we have number of days and its frequency. What we did? We multiplied the weight with the number So 4 into 5 plus 6 into 12 plus 7 into 8 plus 8 into 2 divided by sum of the frequencies. Okay, so 4 plus 12 plus 8 plus 2. So this way you have the weighted average formula. So this way you can calculate weighted mean. So you have a look that this is a grouped data. So in this case we will use weighted mean. Now in this example, page number slide 11, we have an example of 5 houses, and each are nearing to the beach, and their prices are shown here. So 200, 2000K, 500K, 300K, 100K, and 100K. So this is the data for house prices nearing the viewing, having a sea view. So now we are looking at what are the indicators that we can use to describe the nature or the house prices in that area. So if we use the mean method, the answer will become 600K. If we use median, the answer is 300K, and the mod is 100K. So these all of them are giving different answers. So ideally, logically, this is high because of the presence of an outlier. This is in the middle. Logically, two values are above, two are below. This is the most repeated number as shown here. Okay, so we will only consider median as a good indicator if the data is ranked ordinal, but this data is not ordinal, so we cannot use it as an ideal indicator. And we can only use mod if data is nominal, but this data is not nominal. This data is ratio or interval, this data. So in this case the mean will be used, but we should be careful that there is an outlier. So we will use some other indicators to tell that the data mean is this, but it also has outliers. So this is one example. Let's move forward to the next slide. Next is that which one should be the best. So mean is generally used unless there are extreme outliers. Mean is often used since the median is not sensitive to outlier. So mean home prices can be reported for the region because it is less sensitive to outliers. So if you have only one option to give one indicator, then you will use median because it is not sensitive to outliers, and you will report that the median prices in the region is 300K. Then we'll go towards the next indicator, that is once we have the mean data of mean, median, and mod, we can do is we can find what is the shape of the data. So this says that if the mean, median, and mod are equal, the data is called symmetric. The meaning symmetric is that the shape of the data below the mean, below the center line, and above the center line are equal and opposite. So they are opposite to each other. So if you fold this page, you will not differentiate between this side or this side. So in other words, in simple word, it means the rate at which the frequency of observation increased when we started to move towards the mean is equal to the rate at which the frequency of observation decreased when we started moving away from the median. So it means the highest frequency is present in the middle. So this graph is actually frequency distribution that we studied earlier. That high peak means that this number, that is, let's change the color, that the number which is shown here is repeated the most. And since mod is here, so it is confirming that it is repeated the most. Second property the center has is that it is in the middle. It is also shown using the diagram that if you see the number line, it is in the middle. So it is most repeated, it is in the middle, and the mean tells about the arithmetic center. So arithmetic, if the arithmetic center is also coinciding or it is equal to the center value or the middle value and most repeated value, then data will shape like this. This is called symmetric data. If the mean is smaller than median, then it means the data might have longer tail, that it has few of small value outliers, and then majority of the data is high enough. So this is uh, longer tail that is on the left side. So it is left skewed. Then if the data has mean value higher than the median, it means that it has some outliers on the right hand side, but the majority of the data is present here. So it is right skewed data. Okay, so these are few examples that we studied. Now what I will do is I will show you one example how we interpret the meaning of skewed data in our daily life. So try to follow the example. Let's suppose I go into the university and I want to take a survey from the students in terms of what is the GPA of the students. I know that the data of GPA starts from 0 and it leads to 4. So if I look at this number line, okay, if I look at this number line, logically the center, and if I do the interview of what is the GPA of the students, okay, so what will happen is that I would assume that since the average of the data is center of the number line is 2, and when I will do the interview, most of the students should have GPA nearing 2, few of them less than 2, few of them more than 2. But the problem is that if the x bar average and the median and the mod is equal to 2, then the data will become symmetric. It will have a symmetric distribution. But the problem is in real life, students don't consider 2 as an ideal value. They consider 4 as an ideal value. So what happens is you will notice majority of the students nearing 3 or above. The reason is first is they prefer 4 over 2. So it means the ideal value is not in the middle. So it would not be repeated that much. Ideal value is on the higher side. So student will try to repeat that value. Second is that most of the universities where the students where GPA less than 2 are already uh, they are already struck off or they are already on the probation. Few of them are not students anymore, they are dropped out. So you will notice that you will not find many students with GPA less than 2, and it means the most of students with GPA 3 above. So in real life, what will happen is if I create a new number line, it will look like this. So it will have a shape like, let me change to a different color so that it is differentiable. It will look like this. You will have more students nearing 3 to 4 and very few students below 2. So it means if you observe the data of CGPA of students, you will observe that the data is negative skewed. So in this example, I try to explain that what does the purpose of symmetry means. So let's go back to the previous slide and see the diagram. So if the data you are observing has an ideal value in the middle of the data, then data would perform symmetrically. If the data has ideal value on the on the right hand side, then it would be like this. Most of the people will prefer the right hand side number, so it will have a left skewed. But if the ideal value is on the left hand side, and then we people will prefer lower value over the higher value, it will be right skewed. As per my experience, there are very few types of data sets that are जेनेरिकली सिमेट्रिक, यानी बहुत कम डेटा सेट ऐसे मिलेंगे जिसमें जो रिस्पोंडेंट है जिससे वो डेटा कलेक्ट हो रहा है वो डेटा को दरमियान में रखने की कोशिश कर रहा है, ना कि छोटी वैल्यू या बड़ी वैल्यू। इंसानों से मुतालिक ये बात पाई जाती है कि उससे रिलेटेड जितने डेटा सेट्स हैं वो या तो उसको कम करने के पे लगा हुआ है, ठीक है, या ज्यादा करने पे लगा हुआ है। अगर वो इनकम है, कंजम्पशन है, ग्रोथ है, वो ज्यादा करने की कोशिश कर रहा है, वो रिस्क है, लॉस है, वो कम करने की कोशिश करेगा। तो सिमेट्रिक सिर्फ वही नजर आएगा जहां पे दरमियान में हो, अदर देन कि अगर आप कोई हाइपोथेटिकल डेटा क्रिएट कर लें जो इंसान का मियाना रवि को कैलकुलेट करे कि in terms of spending, so if we have a data of spending behavior, so a Muslim customer will not do overspending or not to underspending, because both are discouraged in Islam. So he will do is he will stay in the middle, observe taqwa, and if you observe a data of a true Muslim, you will find out that the spending as a percentage of total income, it will be similar for most of the Muslims in the region, because they will try to balance the not to overspend or not to underspend. ना वो बुखल करेंगे ना वो इसराफ करेंगे, वो दरमियान में म्याना रवि में रहेंगे। सो अगर इस किस्म का डेटा हो, इसके लिए शर्त ये है कि जिसका डेटा ले रहे हैं वो एक मुस्तनद मुसलमान है, और ये इंडिकेटर क्या चेक करेगा कि वो दरमियान में पाया जाएगा। यानी अगर हम एक मुस्लिम कंट्री में जाएं तो वहां पे मुस्लिम कस्टमर्स की स्पेंडिंग का डेटा ले लें, and we compare the spending data with his income and calculate spending as a percentage of income, what we will get is that it should have a symmetric shape, and that symmetry will tell us that the majority of the people in the society are observing taqwa, ठीक है। सो सिर्फ ये एक एग्जांपल है जहां पे सिमेट्री लॉजिकली हम एक्सप्लेन कर सकते हैं कि कब होगी, नहीं तो इन रियल लाइफ इंसानों के रिलेटेड डेटा में हम गारंटी से नहीं कह सकते कि जो डेटा कलेक्ट कर रहे हैं उसमें सिमेट्री पाई जाएगी। So this was an example, an interpretation of skewed data and symmetric data. Hope you understood this topic. So next we are studying is that if we already have the measure of middle using median, so if we want to calculate some other position other than middle, for example, if we have a number line from lowest value to highest value and we already have the middle, we want to find the center of other side. Like if this is middle, so it means it is in the 50th position, and this is 0 and this is 100. And if I want to find 25th position, or I want to find 75th position or some other number, let's say 90th number or 10 number, so this can be done using other location measures. So first of all, we'll start with percentile. Percentile is the way that it divides the data. If we have a data from lowest value to highest value, it will divide the data into 100 parts. Let's say this is 50 parts here, 50 here, then it will add mark that how many parts are there. So it will divide into 100 parts. And then you can ask, or you can find out the position of a particular number in the data. So if suppose the highest, so let's suppose you have some number, let me change the color, you have some number here that is 250. And the advantage of percentile is it will tell you that how many positions in the data are already crossed when you are moving from here to here. It means how much data is smaller than this number, or in other words, how much data is left behind. Yani, it is relative position of this number, how small this number is from the highest value in terms of positions, in terms of data observations or data items. So we will do examples here. Let's start. So the advantage of this is it will convert the data into positions and then it will tell you relative position of each number. So the pth percentile in a data array, it will divide the data into p, and if you want to find some other particular position, that p will be the position. So the interpretation of that pth percentile, let's say you say that I need to find a number which is at 75 percentile, 75th percentile. So that means that you are looking to find a number x which is higher than 75% of data. So you need to look at the position that this number is above the highest percentage. So 100 minus okay. So the p will be between 0 and 100. So this is the percentile. Next type is we study, that is quartiles. What quartile does is that if you have a number line from lowest value to highest value, it will divide it into 4 parts, 0 to 25. We will call it we will call this point Q1, quartile 1. Then 25 to 50, we'll call it quartile 2. Then 75, that is 0 quartile 3. Okay, and then quartile 4. And this will become quartile 0. So quartile 0 will be the lowest possible number. Quartile 4 will be highest possible number. Quartile 2 will be the middle, which is also called median. And then quartile 1 will be in the 25th, which is also called 25th percentile. And quartile 3 is at 75, which is also called 75th percentile. So it cuts the data into 4 parts, and percentile cuts the data into 100 parts. So this is just the difference between two methods. So the method formula is that if you want to calculate the position of a data, so the pth percentile in an ordered array of an ith value is ith position. So example is, let's say you want to find 60th percentile in an ordered array. Your data is in ordered form, means it is arranged in terms from lowest to highest, and you want to find a position where 60% data is below it. ऐसा नंबर कि 60% डेटा उससे छोटा हो फ्रॉम लोवेस्ट टू हाईएस्ट. सो उसने कैलकुलेट किया कि 60 divided by 100 n plus 1, that is, we already know the total number of observation is 19. So 19 plus 1 is 20. 60 over 100 multiplied by 20 is 12. So इसका मतलब अगर आपके पास 19 numbers हैं, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19. If you have 19 observations arranged in terms from lowest to highest value, the 12th position will be your 60th percentile value. So what you will do is calculate 1 2 3 4 5 6 7 8 9 10 11 12. So this is the number. It might have some value in the data file. This is the number, let's say it is 25. So this 25 number in this data is at 12th position, has 60th percentile value. So in other words, it means is that for this data set, 25 is bigger than 60% data. So this is the way we explain percentiles. Let's go move forward and see a few more examples. So what it does, that quartile is dividing the data into 4 parts, 4 equal parts. So let's say we have a data this 12, 11, 12, 13, 16, 16, 17, 18, 21, 22. So we have how many? 9 observations, and we want to find 25th percentile. So the formula is 25 divided by 100, 9 plus 1, that is 2.5 position. So what we'll do is, so it is in between this. So what we'll do, we'll calculate 12 plus 13 divided by 2. So this is quartile 1, or this is 25th percentile, and the answer is 12.5. So it means that in this data set 12.5 number is bigger than 25% of data. यानी अगर ये डेटा हमारे पास हो, अगर हमारे पास ये आंसर आए, तो ये आंसर 25% डेटा से बड़ा है, यानी 25% लोग जो डेटा दे रहे थे या रिस्पोंडेंट्स जिनसे डेटा आया, ये नंबर 25% लोगों से बड़ा है और 75% लोगों से छोटा है. So it is bigger than 25% and less than 75%. So this way you interpret a Q1 or percentile 25. Hope you understand this point. Let's see what's in the next slide. So what we do is that when we have percentiles, let me create one a separate slide and do the calculation. Let's suppose you have a number line. I'm going to draw a number line. Number line is what? It's just a scale where you say that the starting point is the lowest value in the data. Let's suppose this is the data of deposits done by customers today in the bank. All deposit transactions in the bank. So lowest possible will be 0 rupees, and the highest may be value may be 5 million rupees. This is the and your data is from, let's say you assume that there are only 100 transactions done today. 100 transactions हुई जिनमें lowest value थी 0 rupees deposit in the bank. Zero, meant to say zero means that it will be a very small number, 0.10 10 पैसाज. कोई बैंक ने रिवर्ट किए ट्रांजैक्शन 10 पैसाज उसके अकाउंट में गए, and the highest value is 5 million. So there are 100 transactions done in terms of amount deposited into the customers' deposit accounts. Now what we can do is with this data, first of all we can calculate its middle value, that is using median. ठीक है, in median what we'll do is we will arrange the deposit data into increasing order, and if there are 100 transactions we will divide 50th plus 51st transaction divided by 2, and let's say दोनों का आंसर it is somewhere between 2.5 million, the middle transaction. So this is the median, and median is also known as 50th percentile or Q2, quantile 2. So इनके labels हैं, and if you want to find some other number, let's say your manager tells you that calculate the value of 0.1 million. कि 0.1 million किस percentile पे, or he might ask you to find 90th percentile value. He wants to find the X amount of rupees which is bigger than 90% deposits in the bank, or want to find how many transactions were smaller than 0.1 million. So these are opposite to each other. This is the percentile number you need to get the answer. This is the number you need to get percentile. So we will repeat this example and try to get the answer. So I will start with explaining the concept of percentiles and how we can calculate the number from percentile or percentile to a number. So in the next slide, what I will do is that I will show you the one example, and I will draw it here. So let's suppose we have this number line, and I will draw the number line here. So there are 9 numbers. Lowest number is 11, highest number is 22, and we have another number. So we have 2 11s. Okay, and there is 112. So I will mark 2 here, so I know that there are 2 11s, and there is 113. There is 16 and 2 16s, and there is 117 and then there is 18, then there is somewhere 21. So it is not made on scale. So you see that there is a huge, I can make it simplify by adding 22 here and cancel this out. So I will erase it using I will sort it out using, so this way I will draw the number line here. So this is our number line, lowest value, highest value. So I've already discussed. So highest value is the other name for highest value is quantile 4 or percentile 100. So if somebody says calculate me the high percentile 100, the answer is the highest value. Or somebody says calculate me the quantile 4, which is the highest value. So for the lowest value it is percentile 0 or quantile 0. So if somebody says give me percentile 0 value, it is the lowest value in the answer. If percentile quantile 0, it is lowest. And then if you calculate the median, so rather than here, so we'll look at the median. So these are even numbers, and let's, so 1, 2, 3, 4, 5, 6, 7, 8. So I've written the position numbers of the data. So the median is the middle position. So that will be, so if there are 9 positions, the middle will become this fifth position. The 4 are here and 4 are here. So median is 16. Okay, so there are two 16s, so we will not be able to distinguish between which one of them is median, but if they are arranged in this order, then this one is the median. So as the order shows, it is the second 16. So median is here. So we'll say it is percentile 50. It is median, and it is quantile 2. So these are common names that are repeated in the literature. Now in this example, what they are doing is he is trying to ask to calculate the location of 18. So you have given the x and you need to find the p. So the formula was x you have x, and in this example you have three types of unknowns. You need x, I, or p. So x is the value, I is the position, and p is percentile. So x is value. So he is giving us x and he wants to find the location. So location in terms of percentile. So first of all, you have x is equal to 18. You will calculate I from it. How you will calculate I? You will count it where it is, its position is. So I found out it has 7th position. So I is equal to 7th. So the formula that we saw in the previous slide was, let's go back and see the formula and come back here. The formula was I is equal to P over 100 n plus 1. So I will come back here. So I will write formula here. I is equal to P over 100 n plus 1. So I is, we already know, is 7. P is unknown because he's asking for the location. So we need to find the location, and over 100, n plus 1 is 9 plus 1 10. So 0 is cancelled out, it is P over 10. So P will be now P will be equal to 10 multiplied by 7, that is 70. So he is telling us that the number 18, which is located in the 7th position, is bigger than 70% of the data. यानी जो 18 नंबर है डेटा में, जो किसी ने हमें कहा कि फाइंड करो ये कहाँ पे है, तो हमें पता चला कि ये डेटा हमारे 9 ट्रांजैक्शंस में 7वें नंबर पे थी इन टर्म्स ऑफ साइज, इंक्रीजिंग साइज, और ये जो ट्रांजैक्शन है ये 70% ट्रांजैक्शन से बड़ी है. ये 11 से भी बड़ी है, 12 से भी बड़ी है, 13 से भी बड़ी है, 16 से भी बड़ी है, 16 से भी बड़ी है, 17 से भी बड़ी है. सो इट इज बिगर देन 11, 12, 13, 16, 16 एंड 17. So this is the way we calculate from the number to percentile. So this is one example. Now what I will do is calculate the other side, that if you have a percentile, you can calculate a number. So I will clear the screen. And now let's suppose we have somebody asks you to calculate the find the number which is equal to percentile of, let's say, 60. I want to find a number which is bigger than 60% of the data. Okay, so what I will do, so I need I is equal to P over 100 n plus 1. So I is equal to 60 over 100, and that will be equal multiply by 10. So 0 is cancelled here and this 0 is cancelled here. So I is 6th position number. So I will count them: first, second, third, fourth, fifth, sixth. So this is the number 17. So x is equal to 17 is a number which is on the 6th position and it is bigger than 60% of the data. I hope you understand now. Now we will move towards some other applications of percentiles. If we are able to calculate percentiles, what we can do is we can make a box plot. This is a box plot diagram. This is what we do is in the number line, what we'll do is we'll just first of all draw this thing and we write the lowest value here, minimum, and highest value here, and we calculate the median. If the median is in the middle, we draw a line here. If it is not in the middle, we'll see that in the next slide. Then we'll draw accordingly. And then we calculate first quartile Q1, which is 25 percentile. And if it is in the middle of median and lowest value, we'll draw it here, which is 25 percentile, and then 75 percentile. And we'll draw a box here. So this box, the purpose of box plot is, it is based upon 5 observations. This box covers 50% of the data. So what you can say that, suppose you have deposits data from the bank. This is lowest amount of deposit, then this is highest amount of deposit. And if you have this value, let's say it is 0.1 million and this is 1 million, you will say that within this range, my 50% transactions occurred. 50% of transactions were in between this. And if this is 1 rupee and this is 0.1 million, you will say that between 0.1 million, 0.1 rupee and 0.1 million rupee, 25% of the transactions occurred, because it is from 0% to 25%. And let's say this is 10 million. So you can say that from 1 million to 10 million, 25% transactions occurred. So this way you can describe the frequency between different ranges of the data. So this can be done using box and whisker plot. And in the next slide, we will see more examples. So this is the box. If it is a symmetric data, the box will be in the middle, and the distance here will be equal to distance here, and this distance will be equal to this distance. Then the data will be symmetric, and it is same meaning as the symmetry that we discussed later on earlier, where the shape was discussed. Okay, so this is symmetric data. Another function of box plot is, let's see the example, that if it is in the middle, it is symmetric, and left skewed and right skewed. So the box plot can also be used to explain the distribution shape of the data. In the next slide, it is given some pictures just to show that it is one meme that shows that this is the normal data. So when the data is symmetric, we call it normal data. And if it is not symmetric, means the mean is not at the highest point, then it is not symmetric, it is negatively skewed. So we say it is not normal. That's why it is saying I like you, but you are not normal. So it is not normal and it is normal. So this is one joke that I found online. So I showed you the example here. In the next slide, it is showing us how we calculate the distribution shape if we have the data. So let's suppose we have this data already. What we can do is we can calculate the histogram. It can be done using Excel or any other software. And then we join the center of each histogram height. And this is the shape that we are showing here. So this is distribution shape. So it can be done using histogram and made like this. Okay, so this is one example. If somebody asks how you draw this, what we do is we make column charts or histogram and join the center points. Okay, so this way histogram is made. In the next slide, it is creating a box and whisker plot for the data which is very rightly skewed. Why right skewed? Because its right tail is very big as compared to left tail, and in the box right side is bigger than the left side. So and how it is made? So you can look at the data. It is 0, 2, 2, 2, 3, 3, 4, 5, 5, 10, 27. So the highest value in the box plot is 27, lowest is 0, median will be 3, so it is marked here. Since 3 is not in the middle of 0 and 27, it is made where it is logically according to scale. स्केल रख के हमने मालूम कर लिया कि 3 किधर होना चाहिए, वो 0 के ज्यादा पास था, so we draw 3 near to 0. Then Q1 is 2, Q2, Q3 is 5. So this is a box and whisker plot. Its histogram will look like this, and it is positive skewed diagram. So this is a way we use the box and whisker to explain the nature of the graph. And in the Excel or in data analysis softwares, we can draw it quickly, and can be easily drawn by computer automatically. So computer can draw the histogram by calculating these 5 values, 1, 2, 3, 4, 5. It knows where these numbers are. Now we will do some examples and so that you can understand today's activity. So suppose that you have caught 20 fish in the fishing. So there are 20 fish and you calculated the weights in pounds. So these are the weights in pounds. These numbers are very big, but they are fictitious numbers. So these are weights of a fish in terms of pounds. Now you have to tell that what is the nature of data. Is it continuous or discrete? Okay, so that you can understand what is the nature of this data. Is it a continuous data or a discrete data? Then you need to discuss how many ways you can use to check if the data has extreme values. We have discussed few methods in this session. You need to just write what are the ways. Then the question is, if the local authority declares that people who have caught more than 60th percentile will be charged fish regeneration charges. Means if somebody has caught fish whose weight is more than 60th percentile, they will have to pay some tax, so that tax can be used to regenerate fish. Then for the today's data, what is the weight beyond which the tax is applied? Means you need to find out on this data what is the 60th percentile weight, so that you can understand that if the fish has weight bigger than this, you will have to pay the tax. If the fish has weight smaller than this, you will have to not to pay the tax. So this is an applied question for percentiles. So hope you will work on it as an homework and try to understand what are the concepts behind percentiles. And I think today's section you are able to understand how to find center or different locations of the data. And when you have the data for center, you can check the shape of the data. And if you have the data for different positions, you can also check the shape of the data, or you can do some calculations, and few examples are covered in these slides.